Hey guys, what is up? This is Mike Rosada. This is a functional JavaScript lesson, and we are going to tackle the concept of currying in JavaScript. Currying is a super powerful way that you can turn your functions into beasts. If you don't know how to curry, you're in for a treat. First of all, I hope you understand functions and closures because that is going to help you follow this. And if not, you can try to follow it anyway. No one's going to stop you. And I hope you have fun and enjoy it. I'm using Chai to do tests during this video. You don't have to know Chai. It's very simple to read, and I'm only doing it to check my own BS so that when I say something, I can write a test and you can say, all right, this guy knows what he's saying. And the first test I'm going to write is just kind of to show you how Chai works. We tell it, hey, we expect 20 plus 20 to equal 40. I'm going to run my debugger. It's going to run on the right. Nothing happens. And that's good. That's a good thing. That means that everything happened. Everything's okay. But just to make it easier to read, I'm going to throw a success message in there. We get the success message. You still might think I'm a little crazy, so let's make this math incorrect. Expect 20 and 20 to equal 41. We know that's not true. We should know that's not true. And right here, it throws an assertion error. It says that expected 40 to equal 41. So even if you've never used Chai, it's very easy to read, and that's going to be our BS meter for this lesson. So let's get started learning how to curry. Two terms we are going to have to learn, and we will learn them right now. The first one is partial application, and the second one is arity. Partial application and arity. They both have to do with functions. So let's write out a function, and then I can actually rather tell you how those terms apply to this function. So this is a very simple function. It's not even a newer ES6 function. It's a basic, everyday, run-of-the-mill function. It's a sum function. It sums two numbers. It has an arity of 2. Can you guess why? I'm going to tell you. It's because arity is the measurement of arguments that a function takes. And in some programming languages, a function's arity is like it's strictly the amount of arguments you have to call that function with. JavaScript's not like that. JavaScript is veridic in the way that you can pass as many arguments as you want into a function. The JavaScript engine doesn't care. It's going to run that function. It's going to apply that function over the terms, and that's what application is. And partial application is when we partially apply a function to its terms, but it's not just doing this. It's not calling a function with half of its arguments. That's not partial application, and I'll show you why. I'll show you why that's not even that helpful of a thing. We'll try the sum function with just 10, and actually, what's going to happen is it's going to be not a number. And the reason it's going to be not a number, success, the test ran, all right? But I want to dig a little bit deeper into this. I don't want you to just take my word or even Chai's word for this. I want us to see why this is not a number and why this isn't a partial application and why this isn't even useful. Why it's not even useful. Unless you're looking for not a number, then I guess it is useful. So we pass 10 to sum. The JavaScript engine is actually running our code. It's doing this operation right here, A plus B, but it's just binding B as undefined because we didn't pass anything in. We didn't tell it what to do. So it's not throwing a fit. It's not throwing a warning, but it's not doing anything useful either. So what currying is going to do and why it's so powerful is what we want to do is if we don't pass in all of a function's argument, like if we just passed in 10 to sum, well, it's just going to give us another function back, and that function is going to wait for the second argument. And when we pass that in, then it's going to do the work. That doesn't sound so crazy. It might not even sound like it's that cool, but it's awesome. It really is. It allows us to make what's called higher order factory functions, I guess. And I'm going to show you what those are. And in the next video, we're actually going to do some code and we're going to build something fun. And you're going to see why currying is so great. But for now, let's write some tests. I want for sum 10 to return a function. And I want if I call that function with another number, so if I call that function again, that it'll return the correct math. I'm just going to change this to say that I want a function back. So this reads that we want, if we call sum with one argument, it should partially apply. It should just return another function. It shouldn't run a plus b, and it should wait till we're ready for it to do our work. And when we pass it the second argument, then it'll do this operation, passes back an answer. So let's just write that implementation of the sum function. It's not overly difficult. All we need to do is just return a function. And that function is going to take the second argument, right? And this is a ES6 arrow function. It's the same thing as a regular function. The biggest difference between them is that arrow functions don't have an arguments object to them. And if you don't know what an arguments option is, then we don't even need to talk about that right now. So we're going to return from in here our operation, a plus b. We're going to run our tests. They're going to run on the right. It's success. It worked. So this is really cool, but this is the behavior that we want, except with one difference. And I'm going to show you what the difference is right here. You're not going to be running code like this that often, or ever. It's only really good in this test. Normally you would store this to a variable and then call it later, but if we knew that we wanted to add 10 and 30 together right now, we'd want to call it like this, right? Just a regular function, and we want it to totally apply. I'm going to run these tests, and we're going to see that this is going to throw an assertion error. And it's throwing that assertion error because, I'll show you, to be not a number. This is what's happening again. And we could actually pass in as many arguments as we want, and it's going to just do that. It's going to return not a number. It is not a number, but it also trips me up with that a little bit. But it is a function, okay? Because these last two arguments are they're getting passed in, and they're being stored into the arguments object. We can look at that real quick, just so that we see that's what's happening. I'm going to run this. So this is our first call with 10 that returns the function. I'm going to play. So now we should be on this. So we don't care about that either, right? This is what we care about right here. So this is a call right here. And these two, 30 and 40, are on the arguments object that I logged right here. We could access them through that, but otherwise we have no idea they exist, right? They just get they're just extraneous arguments. So it's not very helpful. How could we make this helpful? Well, how about we do this? Why don't we do both of our arguments up here, and we will say that if arguments.length is equal to, and right here is where, should I told you this earlier, I'm telling you now, a function's arity is in its length property. So the sum function dot length, that is its arity. So if we have that, then we want to return the operation a plus b. So the next thing we want to do is if we don't have that, well, then we're going to return the sum function, and we're going to partially apply the argument that is passed in. And we're going to assume one argument was passed in. We're going to assume that the function was called with at least one argument. So here's what we do. We bind that one argument. So if you've never seen bind before, this is very simple as well. This is actually very cool. We're binding an argument to this function. So basically, if a was 10, then we're binding 10 into the function that we're returning. So this is basically what we are returning, this right here, exactly. And next time it's called, say it's called with this 30, the 30 will go directly onto the second argument because the JavaScript engine knows that this is a bound function and that its first argument is bound already. So sum.bind, and that's the function prototype bind method, that isn't going to run our function. It's only going to bind values to arguments in the function. So we could write 10 here if we knew it was always going to be 10. This a, that is the value that gets bound to a. I think it looks a little weird. Maybe it doesn't to you. It does to me. This null is the context of the function. We don't have to worry about that. Context is this thing. So when this function got called, this bound function, it's going to get called where this is equal to null. That's what that is. That's the context. So let's run a test just to see where we're at. So I don't really remember. We're getting a success message. That's good, but let's make sure it truly is a success. This should equal 20. All right, it is a success. It truly is a success. So this is cool. But again, what are we going to write all our functions like this? Of course not, and I wouldn't want you to. We're going to write a utility method that can wrap all our functions and turn them into curried functions, and that is very powerful because a lot of functional programming, you're going to have like so many utilities and they're all going to be curried, and it's just, you're just going to be pulling so much power out of those curried functions. It is truly an amazing thing. So let's write that implementation. First, let's get rid of this sum function. Let's put it up here as a cool little lambda function. And just so you know, I'm sure you do know, but I'm just going to say it for anyone that doesn't, you could write a curry style function like this. Right? I'm going to change this name real quick. So you could write a curry style function like this right here. And basically what this is, it's a lambda function. It returns, this is a function. It's a function that takes one argument. So again, if we passed in all these arguments here, they would just go into the ether. There's no, and it is the ether this time because there is no arguments object. So if we pass in 10, 30, 40 to sum right here, there's no way we can get, they don't really go here. I'm just highlighting that. But they don't go into any arguments object. They're not in scope. We lose them. But 10 is bound to A. So this call or this call here, this here would turn that into a 10 and it would return another function. And even though this is all in one line, this is all in scope. So this function would be returned with A bound as 10. It would basically be this function here. If we passed in sum 10, it would return this. All right. So I'm not trying to patronize you. I'm sure you guys know that. I just want to make sure that everybody does know that because it's very important for some of the stuff we're going to be building upon in even this episode, but next episode. in the next episode and probably the one after that, but then maybe we'll stop. So here's our curry function. As I said, it's going to wrap a function, right? So we're going to have an argument called func for function, and we're going to check. Actually, first thing that we should do before we check anything, we're going to return a function, right? Because that's the behavior that we've been wanting all day. And this function is going to be special in that it takes as many arguments as we need and puts them all into this args token. And if you've never seen this before, this could be called the asdiff token or the asdiff token. But I like args. I think args sounds better. And these three dots, all it does is if we passed in 10, 20, 30, well, if somebody passed that into this function, instead of those going into three separate arguments, they would all get sent into just args would equal array 10, 20, 30. It's very similar to the arguments object, which we don't have in these arrow style functions, but it's an actual array, so it's better. And it looks cooler, and it's shorter. It's awesome all the way around. So just so we know, this is an array. It is an array, and it has any arguments that are passed in here. And then we're going to check if the length of those arguments, we're going to do greater than or equal to, because sometimes we might pass in more arguments than we need. That happens, and we don't want to miss the train and not have our function apply over its arguments. That would be pretty bad. So we're going to check, make sure that they match the arity of func. And if they do, then we are going to take func, we are going to apply, this is kind of like bind, where this first argument is the context. We're going to apply args to that function. So this is going to call the function with args, and apply takes an array, and it basically, I'll just show it right here on the side. Say the array had 10 and 20 in it. Well, it'll call it like that. So there's another method that also does this, that is call. And we could use call as well, but then we'd have to respread out this args, because call doesn't take an array. It would actually we'd have to have the arguments like written out, which is something that it was very difficult to do before. And now with the spread operator, we could very easily use call here. But I am used to using apply. I like apply. I'm comfortable with apply. And if you forget which one does which ever, just remember apply starts with an A, array starts with an A. Somebody told that to me and it stuck, and I hope it can stick to you as well in a good way. So if the args.length is equal to the arity of the function, then we run the function, and if not, then we're going to return the function, and we're going to bind to it whatever arguments we do have, and these we do have to spread out, just like with the call, right? Because bind doesn't take an array, it takes individual arguments. Sorry. So we'll spread those out. So now how do we use this with our sum function, or with any function? Well, what we do is we're going to have to pass the function in to the curry factory. We'll call it a factory, utility factory that gives us curried functions. And it's going to return back this function where func is our sum function. And let's see how our tests do with that. They don't do too good. Why is that? Oh, yeah, of course. Because this becomes totally applied. This would actually be 40, and this would not be a function, so it wouldn't call again. Let's run that. Success. All right, so what's happening here is that this 40 is being thrown away. We wouldn't do that. So this is awesome, right? And we're almost done, but there's something wrong with this curry implementation. So let's see what that is. Let's imagine that we continue to write some functions. We'll do a mult function. The mult function, it multiplies two numbers together, m times n. And if you want, you should write this curry function out. You should write this mult function, and you could write some tests or some console logs, but test it. Write your own function too. Write a regular function, different style functions, pass them into curry. But just know that as soon as you write a function that looks like this, we're going to write vol. It takes width, height, length. That was weird. It takes width, height, and length. It multiplies them together, gives us a volume of a cube. But when we curry this, we're going to end up with a strange situation. And think for a second why this might be strange. I'll give you a hint what's different between these two functions. And this function, the arity, that's what's going to mess it up if we call it one argument at a time. And I'll show you why. So say we call vol with 10. It will be a function. That test is going to pass. If we call vol with 10 and 30, it's going to end up being not a number. And if we call vol with 10, 30, and 20, actually it's not going to equal this, because we're going to get an error here, is what's going to happen, because we partially apply 10 to vol. That goes into width. So now we have a function that is 10 times h times l. We call it with 30, and we end up totally applying the function because we return func.bind. When we do that, we're done with this. This doesn't get called again. It only ever gets called one time. And I'm going to show you that. Let's comment these out real quick, just so you can see. If I put a breakpoint here, it gets hit once. Now it gets, actually, it would be actually more informative if the breakpoint was here. So it gets hit once. See, that's a little bit better. So we have an args array with one thing in it. It should be the number 10. Here it is. See that? 10. Args.length is 1, so it's not greater or equal to func.length, because that's 3. Our vol function has an arity of 3. I'm going to hit play, but if this hits this line again, it will stop, but it's not going to stop. And the reason it doesn't, besides that it will eventually hit an error here, it's because 30 just calls this. So it's basically like doing this. All right, which applies, it runs this function, and it tries to do 10 times 30 times undefined. And we already know from earlier that doing math with undefined is not good. It comes out to not a number, and usually we want numbers when we're doing math. So this should pass though right here, just 2 calls, because that's like doing this, right? So it should have 20 for length, 30 for height, and a 10 for width. Let's run it. Although I have not equal. Let's run it. Success. Success. That feels good. For me, that feels good. I hope you're learning something. So what can we do? I'm going to give you a few seconds to think. You can pause the video. Time's up. Curry is the answer. The answer to the problem is curry. Just curry it again. In a curry, in a hurry, learn you curry. And that's all we do. We just curry that function again. And now it'll take this function. It'll have 2 arguments bound to it. I'm going to duplicate this line here. So it'll have 2 arguments bound to it. And it'll return another curried function, and we can pass in the last argument. So actually, why don't we copy this test as well, and we can just see that the second time it also passes back a function. Let's see, all these tests should pass, and this should be true too, I guess, because a function is not a number, but oh. Yep, there we go. That's awesome. So now we know how to curry. Very powerful stuff, like I said. In the next video, we're actually going to write some code. Well, we wrote code this time, but we're going to write a miniature app, and you're going to see some of the powerful things that we can do with curry, because I know that you might be looking at this and saying, well, that's not that powerful. It just looks cool. But trust me, curry is powerful, and now you are powerful too. Keep writing JavaScript, keep learning, keep being funky with your functional programming. I'll see you guys next time.